right, thank you. We cannot release an app update right now because because Chris is currently on vacation. The provisioning profile doesn't contain all the devices we need for our beta testers. We cannot release an app update right now because our build is broken. The marketing team asks you for the latest screenshots to put on the website or on the newsletter. Oh, this is just such a small bug fix. No user will notice it anyway. We will just wait for the next release in the next few weeks to deploy this change. So these are all quotes we might have heard as a mobile developer in the past, where we're just like hearing these from our coworkers or saying ourselves. And the question is, why do we even have to use these quotes? And the main reason for that is the lack of automation. It is a lot of work to push a new release to the App Store or to the Google Play Store. So when we release a new version to the App Store, and I have to say I'm an iOS developer myself, so if I talk about App Store, it's basically the same for Android and Google Play, obviously. So first off, we have to do some testing, and with testing we have automated tests and we have manual testing. We have to generate new screenshots for the App Store / Google Play, and for each time we have to generate new screenshots, we have to support like all the languages, all the device types, and we have to do that every time we change the design of our application. Then we build our application, and in case of iOS builds, we usually end up in code signing issues, and maybe we have to prepare push notification certificates. Finally, we upload our builds, and in the case of iOS tooling, we also have to wait for processing to be finished. And finally, we can submit the app for review or into production. So this easily takes up the whole day, as you know, and the main problem here is that this is all time you as a mobile developer have to invest. You would probably prefer spending the time working on new features, working on your actual application. So this is why I set out to build something called Fastlane, which is a set of open source command line tools that help you automate all these aspects of your testing and deploying process for both iOS and Android applications. So Fastlane itself consists out of 16 separate tools, not all listed on this slide, that automate all these tedious tasks like maintaining provisioning profile, building application, and uploading everything to Google Play or to the App Store. And Fastlane itself is a tool that connects all these tools into one streamlined workflow, so you can easily automate the whole process. And we don't go into detail to all of these tools, but instead talk about the concepts behind them and how you can use them to save a lot of time during your day-to-day work. And I want to say that all these tools run locally on your machine or on your servers. You have full control over your data, over your credentials, over your certificates, and over all your deployment scripts. And as mentioned before, all these tools are 100% open source under MIT license, so feel free to contribute, to use them, to modify to fit your needs, and yeah, do whatever you want with them. So when we talk about automating your deployment process, what are the main goals? Well, first of all, the deployment should be completely automatic. We don't want to do a thing. We just want to trigger a script or push the button. Secondly, we want to store everything necessary to deploy our application in version control. This is a very key aspect. We want to check out our repo and be able to deploy a new version of the app. And lastly, we want to be developer independent. We don't want to wait for Chris to come back from vacation. We don't want to have this one person who does all the releases, and we don't want a document describing how to deploy the application. We just want this one button. So we will talk about 3 key issues we usually have during deployment and how you can solve them and how much time you're going to save with them. First off, generating screenshots. And by screenshots, I mean the screenshots that are shown on marketing pages, on your website, on Google Play, on the App Store. Secondly, we'll talk about code signing. This is an iOS specific topic, and for all iOS developers, that's usually our favorite topic. And lastly, how you can automate the whole deployment and implement this one push button to deploy your app. So when do we have to generate new screenshots? Every time you publish a new application, every time you change the design of your app, every time there's a new device type or new device, and every time you change the design or add a new language to your application. And it's really hard to do screenshots right. So if you support 10 languages and on iOS you have 6 device types, with each 5 screenshots, you end up with 300 screenshots you have to first generate locally and then upload to iTunes Connect. This takes a huge amount of time. And well, basically you can use tools like Snapshot for iOS to take the screenshots for you. So all you have to do is define a UI test automation file that tells Snapshot how to navigate in your app and where to take the screenshots. And it will then go ahead and iterate through all the device types and all the languages and generate all the screenshots and the report for you. And of course, there's an equivalent for Android, which is called Screen Grab. And it uses the espresso tests. So you can define tap here, take a screenshot here, and it will iterate through the different simulator types. So you generate all the screenshots. And then for both iOS and Android, there are of course toolings available to upload them straight to the App Store or to Google Play, so you don't have to do a thing. And how does this all look like in action? So after you have set up Snapshot, for example, you just have to enter Snapshot in your command line, and it will immediately do all the work. So it will detect things like your project settings and so on, and it will generate all the screenshots in the background. You see the simulator launching up here? The nice thing is that you can do something else on your computer while your Mac generates the screenshots for you. So you can open up your text editor and do something else. And once everything is done, it will generate an HTML-based report, so you get a good overview of how your app looks on the different device types and different languages. And this is a really important thing. Like, you can use this to send this to your your translation service and ask them to review all your screens of all your apps. Let's assume you have one screen where you have a cancel button, and if you support the German language, it's called abbrechen, which is like half the screen. And usually most apps break when you have that. And with this, like, you get a report with all the different device types in all languages. You immediately see that. Alright, now we're going to talk about my favorite topic, code signing and provisioning profiles. So for all the iOS developers out there, you've probably seen this dialog before. And it looks very friendly. You just click this fix issue button and it will do everything for you. And that's a very Apple-like interface. That's how it should work, right? The problem is that it breaks things from time to time, so we shouldn't really use it. So if we talk about code signing, we have to understand some of the basic concepts. It's actually really, really simple. You just need 3 components. First, you need a certificate/code signing identity. You can use a tool like CERT for that, so it will generate all that for you. For a code signing identity, you need a matching provision profile. This is really important that these 2 things are connected. Otherwise, you will end up with cryptic code signing error messages. And finally, you use that provision profile to build and sign your application, and you end up with a signed API. So the concept is really, really simple. The problem really is that you run into code signing errors at a later point during the deployment process where it is too late to actually fix the issue. So you can basically just call these 3 tools in this order, and it will generate a valid API file. However, this is still a lot of work. This is 3 commands. That's too many. And additionally, it still has a problem. When you create a certificate, it is only stored on your local machine. The private key is only stored on your local machine. That means there's a lot of overhead of syncing this between your build server, between your local machine, between your new machine if you have multiple Macs, and so on. So we recently worked on a new concept for code signing, which is basically sharing one code signing identity across the team. So the way it works is basically you use a Git repo, which is encrypted, to store your private key, your provision profile, and your certificate there. And then every employee who has access to this Git repo and has the password for the encryption can then install the code signing identity on their machine. The useful thing about that is that you just give permission to the people who are able to deploy to the App Store or who are able to deploy a new ad hoc release, and they can immediately build and sign your application without having to manually do all that. So, and why do we do this? Well, if we don't use this concept, we have a lot of troubles with keeping devices in sync, keeping provision profiles in sync. Additionally, how does onboarding for new employees look like? New employees should be able to build and sign the application and install it on their phone. And lastly, you will have less random code signing errors, and your Apple Developer Portal won't look like this anymore. And yeah, if you're interested in this concept, you can go to codesigning.guide, where this is all described in detail. And this is not something you have to do. This is something you can do if you want to make your life easier and make it easier for new people to onboard on your team. And this is all implemented using Match. Like you can implement this concept easily on your own, basically just copying that into your like Git repo and so on. But you can also use Match, which is another Fastlane tool, to do all that for you. How does this look in action? So yeah, I decided not to do live demos today. We run Match init. You specify a URL to a Git repo in which the certificates will be stored. This generated a configuration file called match file, and then you run match app store to create a valid app store certificate and provision profile, and that was all it. So it generated all that, stored it in Git, pushed it back, and everyone on your team can use that. All right, to the last topic, automating your deployment. So deploying something to production, usually, what I mean is if like your product manager or your boss asks you for the latest build of your application, you will usually go through these steps over and over again. You increment the version number, you commit and push, you make sure you have a valid version profile, you build, you export, you upload it to some beta testing service, you add release note, and then finally distribute everything to your testers. But our goal is to like reduce all that to a push of a button. And you can do that, and many of you probably do, like with custom shell scripts. However, it is really hard to maintain those things because APIs changes and so on. And when you use Fastlane, you can use a so-called fast file, which contains all information to deploy your application. You can see it will call Jim to build your application. You will upload everything to Crashlytics beta and then send a message to Slack. And in Fastlane, you define which step to run in what order, and it will make sure to execute them and that every one of them succeed. And if one of these steps fail, Fastlane will stop executing the whole lane. And this is all basically a Ruby configuration file, so you store that in version control. Again, all the knowledge should be stored in version control. So if we look at the example we've talked before, how would that look like for our use case? We increment the version number, we commit the version bump, and we push it to our Git remote like github.com. Lastly, next up, we use cert and sci or match if we want to use that, and then Jim to build and sign our application. This is the combination we just talked about previously. And lastly, we upload everything to Crashlytics and post a message to Slack that our build is ready. So all these actions, they're all built in. However, you can easily like add your own actions. You can build your own actions. You can use your existing shell scripts, Python scripts, Ruby scripts, whatever. So you can easily extend it to fit your needs. And if we look at this whole file now, how does the trim action know what provision profile to use? Or how does Crashlytics know where to find the IP file? And these are all things that Fastlane takes care for you. So it will pass on information from one build step to the next one, so you don't have to think about it. So how would you run the beta lane, which is in the top lane? You just run Fastlane beta. And how this looks in action, for example, this is a pilot release. Pilot is a tool to upload something to Apple Test Flight in iTunes Connect. So it will first build our application using Jim. That's how the output looks like. And then it will use the iTunes transporter, which is built into Xcode, to upload everything to iTunes. And while running Fastlane, this is usually how the user interface looks like. Again, this is all self-hosted application. You install it locally. It is a Ruby gem to install. So the user interface is a command line tool, and it will show all the commands it is executing in orange, and it will show you summaries of the parameters it got. So it's very easy to distinguish different builds, and you can see what parameters you passed. In particular, I want to talk about one tool called Spaceship. And as you may have seen, like many of these tools require some kind of communication with Apple's backends. Just to talk about Google, for Google it's easy. Google provides an API. There is no need for its own tool for that. But Spaceship is an API client for the iOS side. So basically, Spaceship unifies 3 different API endpoints from Apple: iTunes Connect, the Apple Developer Portal, and Xcode's backend API. And it unifies all these APIs and provides one unified Ruby object-oriented API you can use. And many of the Fastlane tools use that as an underlying communication layer. The great thing about it is that you can now build your own tools. You call spaceship.login, provide your email address, and then you can, for example, fetch a certificate, or you can fetch an application and then get information from that. So this is its own Ruby gem. This is also open source, of course, and you can build your own tools with that. And if you want to take a look of how you can use it, you can just, after you install Spaceship, you have a new Spaceship command in your terminal, which is the Spaceship Playground. And here you can like play around, and as you can see, for example, we fetch all applications available on iTunes Connect. So this is all like non-Mac specific. This runs on Linux as well. That means you can run it on a server as well. And to demonstrate that, I also built a tool called Boarding, which is basically easier onboarding for test flight beta testers. But the main reason I built it was to demonstrate what you can do with Spaceship. So you have a simple Rails application where the user can just enter their name, click on Get Beta Access, and in the background, the Heroku server will connect to iTunes Connect, add the tester, send out an email for the build, and it all happens on the server without you doing anything. And this was a very short introduction of what you can do with Fastlane. And if you want to get more information, go on fastlane.tools and check out the GitHub repo. Thank you. And I believe you have time for questions. Okay. Security concerns around your Apple ID? Right, okay, the question is about security concerns around the Apple ID and communication with Apple. So communication with Apple runs all over HTTPS and partly over built-in tools like iTunes Transporter. Your credentials are all stored in your local keychain. However, you can even disable that if you don't want that. And again, your credentials never leave your local machine or your local server. So on the first run, you will be asked for the credentials, and then it will be stored in your keychain. Does that answer your question? Okay, cool. Yeah. What's next for Fastlane? So currently we're it's not only me. I started this project on my own. Now it's more people helping me with it, and currently we're trying to handle support. There's so many new users, and it's like a ton of work. However, I'm currently working on things like adding two-step verification for Apple IDs. That's a big thing, and we are currently also improving like the whole, making everything more stable, having better test coverage, having better network requests. We recently rolled out something that most users never saw, basically handling downtimes from Apple in a better way. In particular, if Apple servers are currently slow, it will retry requests because it knows this error code only happens when there is like overload of the server. So we are making a ton of changes under the hood, not so many like currently user facing. And Patrick? Yeah. Did anyone from Apple reach out to me to get rid of the private APIs? So no, only like the engineers from Apple like it, I guess. But the thing is that I'm not like abusing the API for anything. I'm just like building tools to help developers. It's not like I'm doing something I shouldn't be doing. And basically I'm doing something that Apple should do, like providing better tooling in this example. I'm just doing that. Right, yeah. So yeah, I work at Twitter now, and that means I can work better together with the Fabric team. In particular, what we're working on right now is uploading simplification files from your local machine to Crashlytics. And what I've worked on last week was downloading simplification files from iTunes Connect. And as you may know, if you have Bitcode enabled, Apple recompiles the application and generates new simplification files. So what I built is a tool that downloads all these simplification files and can upload it to Crashlytics crash reporting, but also to Hockey and Sentry and to any other crash reporter. Other than that, like there's nothing planned that you have to use Fabric. Like Fastlane is still a standalone thing. All right, I think we're good. Thank you.